Okay, so this will be the last video on probability that I'll share. And today we're going to talk a little bit more about conditional probabilities. In other words, the probability of B given A. Now you'll look at the formula that I wrote here, and it shouldn't surprise you that that formula is true since the probability of A and B is equal to the probability of A multiplied by the probability of B given A, okay, all that we're doing is we're isolating for the probability of B given A. So we're dividing both sides, which is why we get the probability of A and B divided by the probability of A equals the probability of B given A. Now you'll notice that this is my condition, right? Event A is my condition. And it's no coincidence that the probability of A is my denominator. So the condition is my total. So out of all of those events, okay, this is my denominator, and then this is my numerator when A and B both occur. Okay, so how can we use that? One very obvious way we could use it, the probability it will rain on Tuesday is 0.6. So the probability that it rains on Tuesday is 0.6. Probability it will rain and we will have a polar bear meet on Tuesday is 0.05. So the probability that will rain and we'll have a polar bear meet is 0.05. Okay, what is the probability that we will have a polar bear meet if it rains tomorrow? So I'm asking you for the probability that there will be a polar bear meet given rain. I'm asking you to find that. Okay, so um, remember that's rain, right? So we'll call this, for the sake of argument, we'll call raining A, okay? Polar bear meet B. So we're trying to find the probability of B given A, okay? And that's as simple as finding the probability of both A and B divided by the probability of A, which in this case is 0.05 over zero point 0.6, which is 1 over 12, which is 0.083. Okay, so let's say a much more complicated problem. Cavis is 40% likely to run on a 4x1 at the state relays. Coach Mackinson has predicted that if Cavis runs on the relay is 75% likely to place. However, he feels that if Cavis does not run on the relay is still 56% likely to, that should say, place. What is the probability of 4x100 relay places at the state relays? Okay, so this is a complicated question because there are multiple things happening. Cavis runs or doesn't. And then after that, the relay places or doesn't. Okay, so there are two events, but each event has two different things that could occur. So the best way to tackle this is to draw a probability tree, okay, and draw it sequentially. So what happens first is Cavis runs or he doesn't. So either Cavis runs on the relay or Cavis does not. That's K complement. Okay. The probability that he runs on the relay is 0.4. So the probability that he doesn't run is 0.6. Now, he runs on the relay, they place or they don't place. Even if he doesn't run on the relay, they place or they don't place. Okay, going back here, Mackinson has predicted that if Cavis runs on the relay is 75% likely to place. So if he runs, 75% likely to place, which means 25% likely not to place. If he does not run on the relay, 56% likely to place, which means 44% likely not to place. So there's a nice probability tree, okay? And what's nice about this probability tree is that now I can determine the probability of any of the four events occurring. Now, I said four events. Cavis runs and the relay places. Cavis runs and the relay does not place. Kvis doesn't run and the relay places. Kvis doesn't run and the relay does not place. It says, what's the probability of 4 by 100 meter relay places at the state relay? Well, that's here or here. Well, this occurs 0.4 times 0.75% of the time, which is 0.3. And this occurs 0.6 times 0.56, which is 0.336. So either this happens or this happens, which makes this total probability 0.636. Now, if the relay places, so the relay is placed, that is my condition, what is the probability that Kvis ran on it? So the probability that Kvis ran on it, given that the relay places. Well, just going back to the formula that we used before, that's the probability of both divided by the probability of my condition. So my condition we just determined is 0.336, and the probability of both is Kvis relay placing 0.3. So 0.3 divided by 0.336 is 0.8929. Okay? So we'll try one more of those probability tree problems. Suppose at a local high school, 15% of students attend a dance after drinking alcohol. Breathalyzer test will read positive 92% of the time when a student has been drinking. Will also read positive 12% of the time when a student has not drank alcohol. So it's a false positive. Student is chosen at random and tests positive by this breathalyzer. What is the probability a student drank alcohol before the dance? So the probability that the student drank given a positive result. So what is the probability that it is a big deal when it should be a big deal? All right, so we'll draw a probability tree again here because I'm going to want to find the probability of both and divide it by the probability of my condition. So sequentially, what happens first? Well, either the student drinks or doesn't. 15% likely to drink, 85% likely not to. If they do drink, it's 92% likely that it is a positive result and 8% likely that it is negative. And if they do not drink, it's now only a 12% likely to be positive and 0.88 likely to be negative. So drink and positive is drink and positive 0.15 times 0.92 which is 0.138 divided by positive, which is either here, which is 0.138, or here, which is 0.85 times 0.12. So 0.15 times 0.92 or 0.85 times 0.12. So we'll determine what that is. That is 0.24. So 0.138 divided by 0.24 is 0.575. So if a student did have a positive test result, then it is 97.5% likely that they did drink alcohol before the dance. Okay, so now it's time for us to practice. If only I could turn this off.